Now here we summarize all that we have studied about the truth tables and different equivalent statements about the various types of logical connectives. So that is what we call as algebra of statements, which gives us a summary of standard equivalent statements. So we take them as laws and use them directly in solving the sums of logic. So first of them is what is called as idempotent law. Now the word idempotent means like something which is related with itself. Okay. So by this what do we mean is, if you see the first statement given there, that is P or P is equivalent to P itself, and the second one is P and P is also equivalent to P itself. So why it is called as idempotent? Because like we are doing P and disjunction with P itself. Okay, so it's the disjunction of a statement with itself that gives us the same truth value. So let us understand from where this comes so that we'll easily know how to remember that. Since the first one talks about the OR, let us prepare or recollect the truth table of P or Q. Okay, so we know that it is TT, TF, FT and FF, and for OR it is all true except when both are false, the OR is false. Now here what does this P or P means? That if both the truth values of the two parts in the disjunction are same, that is either both are true or both are false, then let us look at what does it mean. See, when both are true, the answer of the OR is also true, isn't it? So it is same as whatever common truth values were there of the two statements. On the other hand, if you have both the individual statements as false, then you see here the answer is also same as false, right? So this is what is the meaning of idempotent law. The result will be same as the individual truth values of that particular statement. And interestingly, the same thing follows for conjunction also. So here let us prepare the column for conjunction also. We know that it is true only when both are true, and rest of the cases it is false. So interestingly, we will come to know that the conjunction also follows the same law. So in first case, when both the statements P and Q were true, the conjunction is true, and when both are false, the conjunction is also false. So that is what is the idempotent law is. Let's go ahead and see what is called as commutative law. This we are very much familiar from other areas of mathematics, that is P or Q is equivalent to Q or P, and secondly P and Q is equivalent to Q and P. So by commutative law we mean the result of an operation is same even if we change the order of the individual elements that come in that operation. So like we know that addition is a commutative operation. So that is what is the meaning of commutative law, and it applies for conjunction and disjunction. Moving on, we have associative law. Now this appears when you have three elements which are connected with the same operation. You see, that's very important. We must have the same operation among all the three. So we have P, Q, R joined with OR. Okay, so now here we have a dilemma, that is which two to club first. So the associative law says that as long as it's the same operation amongst the three, you can associate any two first and then associate the answer with the third one. Okay, so here first of all we can do either P or Q and then do the OR with the third element, that is R, or we can merge the second and third, that is Q or R, and then do the OR of that with P. In fact, alternatively we could have also done P or R first and then merge that with Q. That will also be the same thing. And exactly same rule applies for conjunction also, that is you can associate any two conjunctions, any two elements first with the conjunction and do the conjunction of that with the third element. But just to repeat, the associative law applies only when there are three elements joined with the same operator or same logical connective. So both should be AND or both should be OR. So naturally the question arises, what if there are three elements but they are having two different logical connectives, that is one AND and one OR. So that is where we have a next law called as distributive law. This is where the brackets are of immense importance because that will mean differently if the brackets are not put in the original statement. So if we have P, or Q and R, then like what we do in algebra while opening the brackets. So we open the brackets by distributing P to individual elements inside the bracket and then connecting those results by the operation which is inside the bracket. So if you relate this with x into bracket y plus z, what we do in algebra. So what we do is we do x into y. So there is outer operation is multiplication. So we multiply x with y, then we multiply x with z, and then connect the result with the operation which is inside the bracket. So therefore we write plus here. So exactly in the same way we use the distributive law for disjunction over conjunction. So we have P or Q and R given by P or Q and P or R. And even if we replace or with and with or, the same logic remains. So in the second statement we have P and Q or R to be equal to P and Q or P and R. It's plainly what we call as opening the bracket. The important point to note here is while solving the sum, sometimes we are given the expression like the one on right side. So we have to apply the distributive law in the reverse manner. That is, like we expand the bracket, similarly the opposite process is we can take some element common from both the expressions. So if you look at the right hand side of the first statement, you see that P is common in both. So therefore that P is taken outside and then we write the remaining bracket. So that also we have to use wherever required. Let's move on. And now we have what is called as identity law. Now this is when one of the elements in the conjunction or disjunction is either true or false, then based on that we decide the result. Now in case of OR operation, when at least one element is true, we know that the result is straight away true. There is no need to worry about what is the truth value of P, because whether it is true or false, the answer is going to be true only. Now in case of OR, if one of the element is false, then the answer will depend on the truth value of the other unknown truth value. Because suppose let us consider we have true or false, that is equal to true, we know. But if we have false or false, that will be equal to false. So when one element is false, the result will be same as the truth value of the other unknown truth value. So that is what is the meaning of this. Now similarly, we can now guess what would be the case for the conjunction. Let's see the third statement, that is if you have P and true, that means in the conjunction one of the element is true, then the result will follow the other unknown truth value, and this also we can verify from the truth tables easily. Whereas lastly, if one of the truth value is false in conjunction, straight away the answer is false. That's the identity law. Going ahead, we have complement law, which states that P or negation P is true and P and negation P is false. So here, since we have the two opposite truth values, one of them has to be true and the other one has to be false. So if you take the OR of true and false, clearly one of them being guaranteedly true, the answer will be definitely true only. Whereas when we do the AND of the two values which are true false pair, then one of the value being false, the answer will be straight away false because it is the conjunction. That's the complement law. Then we have involution law, or basically that's the negation law. So negation of negation P is P, that we know, that's very trivial. Then negation of true is false and negation of false is also true. That is also very fundamental definition. Then we have De Morgan's laws, we have already seen, which give the negation of conjunction and disjunction. So while doing that, we negate individual statements and replace AND with OR and AND with and OR with AND. Moving on, we have conditional law. This also we have seen in the definition of what is a conditional or an implication statement. So the implication P implies Q is equivalent to negation P or Q, and that is also equivalent to negation Q or negation P. And if you recollect, this last particular construct is nothing but what is called as the contrapositive of the original implication, right? So contrapositive is always logically equivalent to the original implication. That is a conditional law. And lastly, we have another curious law that is called as absorption law. This we have to remember as it is properly, which says that P or into bracket P and Q is equal to P, that's equivalent to P, and P and into bracket P or Q is also equivalent to P. So if you have this particular LHS, then what it means is this entire bracket is kind of absorbed inside P, so that bracket vanishes and just P remains. So that's the way it is. So to apply the absorption law, first of all, the condition is that whatever is the outside single statement, the same must appear inside the bracket also. Okay, only then we can apply the absorption law. So based on these laws, we can simplify the complicated compound statement patterns, because often every time it's not convenient to make the truth tables, because the truth table may become very large with lot of columns. Okay, so instead of that, we can directly apply the laws and simplify the statements. So we will solve a few examples based on use of these laws.